Dear students, in the last video, we discussed about the domain and range of trigonometric functions. In this video, we'll be talking about domain and principal value branch of inverse trigonometric functions. So in the last chapter, in Relations and Functions of class 12th, we have studied that the inverse of a function exists if the function is 1, 1 and 1, 2, right? So that means there are many functions which are not 1, 1, on 2 or both. And hence we cannot talk about their inverse, right? In class 11, in the last video, we studied about the trigonometric functions, right? And as if whatever we have studied about the domain and range, we have understood that the trigonometric functions, for example, sine function is not 1, 1. Why? Because if you talk about sine function, sine 0 also gives you 0, sine pi also gives you 0, sine 2 pi also gives you 0. That means sine function is not a 1, 1 function. If it is not 1, 1, it can't be invertible, right? So to make it invertible, what we have to do? We have to restrict the domain of trigonometric functions so that it becomes invertible. I hope I'm clear, right? So we shall now be studying about the restrictions on domains and ranges of trigonometric functions, which ensures the existence of their inverse, right? And we observe their behavior through graphical representations. I hope I'm clear. In the last video, we discussed about the domain and range of trigonometric functions. Now here, I am taking an example of sine function and inverse of sine, and then I will be giving you responsibility to understand the graph of inverse of other trigonometric functions and the trigonometric functions. Okay, so let's discuss the graph of sine function. So this is the graph of sine function. Okay, so this is your minus pi by 2. This is your pi by 2. This is 0. This is pi, 3 pi by 2. And then we have 2 pi and so on and so forth, right? So the domain of sine function is the set of all real numbers and range is the closed interval. Range is the closed interval minus 1 to 1. Actually, sine function we have to restrict, and it can be restricted to any of the intervals where the domain is not giving you, it is giving you, say, a single value, single range, right? So here we have pi by 2, minus pi by 2, pi by 2. We have 1, 1 function. Pi by 2 to 3 pi by 2, you will be getting 1, 1 function. Your 3 pi by 2 to further here, you will be getting a 1, 1 function, right? So we have many restrictions here. So you can, sine function can be restricted to many intervals like minus 3 pi by 2 to pi by 2, as I just discussed. Then we have minus pi by 2 to pi by 2 also. Then we have pi by 2 to 3 pi by 2, and so on. So these intervals, these branches make the function 1, 1, and its ranges, all the ranges are from minus 1 to 1, right? So we can therefore define the inverse of sine function in each of these intervals, and we denote the inverse of sine function by sine inverse, or few people call it as arc sine function. So this is also correct. Thus, sine inverse is a function whose domain is minus 1 to 1, and range could be any of the intervals. Okay, and corresponding to each interval, we get a branch of the function sine inverse. The branch with range minus pi by 2 to pi by 2, here to here, is called the principal value branch of sine inverse. When we refer to the function sine inverse, we take it as the function whose domain is minus 1 to 1, and the range is minus pi by 2 to pi by 2. I hope I am clear. Now let's quickly draw two graphs of the function, one sine inverse function and sine function in one picture. So here, this is the graph of sine function. And I'm drawing the graph of sine inverse function also. I'm trying to make a clear image of it. Okay, so when I'm drawing the graph of sine function and sine inverse function, it can be shown that the graph of an inverse function can be obtained from the corresponding graph of original function as a mirror image, or you call it reflection, along the line y is equal to x. And this can be visualized by looking the graph that you can see here also. Okay, so I hope I'm clear, right? Now, similarly, we'll be talking about other graphs also, not much. Further, quickly discuss sine inverse x, its details and graphical representation we have already done with. Domain -1 to 1, as we just discussed. Range minus pi by 2 to pi by 2. So basically, when I was talking about sine theta, the domain of the function, if you remember, was all possible real numbers. And the range was -1 to 1. So basically, कहाँ से कहाँ तक value sine function की जाती है was my motive, right? So the value of sine theta goes from -1 to 1. So this was the range. And here domain was all possible real numbers जो हम put कर सकते थे. But when I'm talking about inverse of a function, my theta becomes the range, or you call it principal value branch, and my range becomes the domain of the function, right? So in that case, range will be minus pi by 2 to pi by 2, and domain becomes -1 to 1. That is why the graph of the function looks like that. This is the graph of sine inverse x. Okay. Moving further, cos function. So if you talk about the cos function, it goes like that, right? So what is the domain? Domain remains same, -1 to 1, no change at all. But when we talk about the range, it becomes 0 to pi. 0 to pi means here to here, and you know why. If you've understood the the last video very well, the trigonometric functions domain and range, you'll be able to understand the reason why range of the function is 0 to pi. Basically, at cos closed interval 0, this and up to pi, this is 0, and here pi, your function is giving you unique image, right? The function is 1, 1. Moving further, tan inverse function. Now here domain will be all possible real numbers, but range is minus pi by 2 to pi by 2 open interval. Why minus pi by 2 to pi by 2 open interval? Because at minus pi by 2 and pi by 2, the function becomes not defined. I told you tan theta, sine by cos theta is 0 at pi by 2, right? And 3 pi by 2 and 5 pi by 2. So that is why minus pi by 2 to pi by 2 will be open, right? Will not be included in principal value branch. In the same way, cot inverse x, which means domain is all possible real numbers, range is 0 to pi open interval. I hope you know the reason. Moving further, secant inverse x, domain -infinity to 1 closed interval, union 1 to infinity, where 1 is closed. I want to know the reason why -1 and 1 is closed. I have discussed that in the previous video. You have to tell me here now. Okay, you have to send a message. Now, range is 0 to pi closed interval except pi by 2, because at pi by 2, my function becomes not defined. So I am not going to put pi by 2 as range. Moving on to cosecant inverse x, domain is -infinity to -1 union 1 to infinity, and range is closed interval minus pi by 2 to pi by 2 except 0. Why except 0? Because at 0 my function becomes not defined. So these are the inverse trigonometric functions, the domain, range, graph, and everything. Understand it carefully. And from the next video, we will be solving good questions related to the concept. Keep in touch, stay tuned, and don't forget to like, share, and subscribe the video. Thank you.